to the cloud. Okay. All right. So let me first go over the test. I won't solve all the problems in the test because we don't have time, but I'm gonna make, as I said, I'm gonna make a couple of comments about the most common mistakes in the test. So let's discuss the second test first. The first problem. I think most of you got this problem right. So, but there is only one thing. Some of you, instead of using, the table 2 to find the answer, to find the probability, the probabilities, they try to use the formula with the n choose r, etc. But here in this first problem, so let me just write down again the problem for you, just to remind you that was a problem. So it says recent study shows that 20%. So as I said before, when you see like a percentage in your first sentence, you see a percentage, then that will be a binomial distribution. And we discussed binomial distribution in sections, so section 6.2 and 6.3, and also in section 7.6. Okay. So there's this percentage. It says that 20% of New Yorkers are tested positive to the COVID, tested positive to COVID, etc. And then at the grocery store, in the Bronx, there are 6 customers, right? We have a group of 6 people. So we have a group of 6. Okay. So as I said, so this would be a binomial distribution because you have this percentage, like in your first sentence. So the probability of success, P. So this is the probability of success. That will be equal to the percentage, right? That's the 20%. And then there's N, which is the number of trials. That's the number, that's the size of the sample. So we have this group of six people. So then the size of the sample is 6. So that's the N is equal to 6. All right, so for example, like in the first question, it says, you need to find what's the probability that exactly 2 customers have COVID antibodies in the blood. So you need to find the probability that exactly two customers have COVID antibodies in the blood. So exactly 2. So you need to find the probability that the number of successes R is 2. So to complete the answer here, guy, all you have to do is just to use the table number 2. So you go to the table number 2 with probability of success P equal to 20%. So 20%, that's 20 divided by 100, that's 0.20. And the N is 6. And you want your R to be equal to 2, right? So if you go to the table number 2, just right here. So this is the table number 2, right? The first column, that's your N. In our problem, the N is 6 because we have a group of 6 people. So you need to go all the way down to 6. And then you need the number of successes R to be equal to 2, right? So next to 6, in the next column, that's your R. And it goes from 0 to 6, right? So you need R to be 2. And then your probability of success P is 20%. That's 0.20. So as you can see in the top, you have P, and it starts with 0.01, then 0.05, etc. So you need to go to 0.20, right? 0.20. So if you go down to where N is 6 and R is 2, then the answer would be 0.246. Okay, so the answer here, this problem, it's 0.246. So you don't need to use any other formula, just a table, right? And again, to repeat again, there's your N, you need to go to N equal to 6, right? This is in the chart, table 2. And then next to N, there's R. So there's like 0, 1, 2, 3, 4, 5, 6 next to 6, next to your n. Our R is 2 because it says exactly 2. So our R is 2. And then in the top, that's your P. You have like 0.01, 0.05, 0.10, etc. Our P is 0.20, right? So you go down where n is 6, R is 2, and you get the answer 0.246. So this is where you can get your answer. All right. So whenever you have this binomial distribution where n, the number of trials, the size of the sample is less than 20, right? This 6 here, this is less than 20. So you can use this table number 2 because largest n in the table is 20, okay? All right. So any question about the first problem in the test? This says there's this expected number, right? Expected number, that's your, that's the mean. Expected number, so the expected number, that's the mean, right? That's the mu. So that's the mu, the mean. So that's a mu. And we said in section, 6.3, the mu is just n times p. The standard deviation, it's just, standard deviation. This is just square root of, just to remind you of the formula, it's square root of n times p times q, where q is, it's 1 minus p. So your p is 20% or 0.20. So that's 1 minus 0.20. So that's 0.80. Are there any questions about problem number 1 in the second test, right, guys? Any question? Well, as I said, most of you got this one, this problem correct. So I'm gonna check the chat. Let's see. Okay, cool. All right, number 2. Okay, problem number 2. So when you read the problem, yes, please.
When you say problem number 1, there's 3 sections. The section number 3.
No, I'm talking about the test. I'm not talking about the review sheet. This is the test. I'm discussing the test.
Am I talking about the test? Test 2, right?
Yes, test 2. Right. There are 3 questions. Yeah.
Yeah, that's what I mean. Test 2.
Mm-hmm.
Are you already on part 3 of the number 1 question? Because the problem 1 has 3 sessions.
Yeah, so no, because we don't have, I don't have time, to solve the problems, right?
Okay, yeah, I don't want, I just have a question on the part 3, if that's okay, of problem 1.
Oh, okay. Yeah, so that's, oh yeah. So that's, so you mean the expected number, right? The expected number of customers having COVID, right?
Yeah.
That's yeah. So that's,
was there oh my gosh, so nice. So besides having to have that formula, the NP and Q square root, was there anything else to do on that session?
No.
No, okay.
No. So of course you need to, here I didn't compute the mu, right? So it's mu, it's like, n, as we said, they have a group of 6, p is 0.2. So I think the answer would be 1.2, right? And the same for the standard deviation, right? So yeah, if you compute your standard deviation and mean, then you are done. Yeah. Okay. Nothing else to do. Yeah. Okay. Sure. All right. So now let's discuss problem number 2. Problem number 2. So when you read the problem, right, you see it says there's this X. There's no percentage. It says X has a population mean mu and sigma, right? There's a mu and sigma given. So usually whenever you see like mu and sigma given, both, right? Both mu and both. So here in this problem, both mu and sigma are given. Okay. So this is probably a question about section 7.3, where we discuss the normal distributions. And so the thing here with this normal distribution is what we do when you see this mu and sigma given, what we do is we usually convert our variable x to this variable z. So then you can compute your probability, right? So for example, here in this problem 2, it says, mu is 40 centimeters and sigma is 4 centimeters, right? And then it says like, what's the probability that the length of a fish caught in the avalanche lake is more than 38 centimeters, right? Is more than 38 centimeters. So we wanna find the probability that x, so x is supposed to represent the length, right, in centimeters of a fish caught in the lake, right? You want your x to be more than 38. So we want to find the probability that x is more than 38. More than 38. So why the mu and sigma are given? That's because you can convert this x to z, right? And then use this table number 3 to get the answer. So what we do here, we convert x to z, right? So like x more than 38 minus, so just to remind you the formula, so z is x minus mu over sigma, right? So it's 38 minus 40 over 4. Sorry, this is z, of course. This is z more. So z more than 38 minus 40 over 4. And then, then you have your z more than, so this is -2 over 4. So the answer will be -half, -1 over 2, -half, right? Oh, so -half, of course, that's -0.5. All right, so the point is, when you convert this x to z, and then you can use this table number 3. Okay, then use the table 3. Just be careful, this is more. So when it's more, then that will be the area to the right. And we said the table gives us the areas to the left. The table gives us the areas to the left. Areas to the left. So the problem here is to convert this area to the right, or express this area to the right in terms of the area to the left. And we said the area to the right, it's always 1 minus the area to the left. So z less than -0.5. This is less. So this is the area to the left. All right. And then use your table 3, right? So you still have this 1 minus, don't forget it's 1 minus, and wherever number you get from the chart. All right, so it's z less than -0.5. So you need to go to this chart, so table 3, where z is negative. Is -0.5, so we need to go all the way down to -0.5. Nearest hundredth is just 0, so the answer is 3085. So it's 0.3085, right? Etc. So all I'm saying, guys, whenever you see like this mu and sigma both given, so it's probably at some point you need to convert this variable x to this variable z and use this table 3, right? Of course, there are like 3 different situations, right? There are like 3 different cases. Sometimes you have like more than some number, or less than another some number, or between 2 numbers, right? More, that's the area to the right. Less, that's the area to the left. And between 2 numbers, so then you need to take like difference between the numbers you get from the table. So is there any question about problem number 2 in the test? And again, I think most of you got this one right. So let me check the chat. All right. Now, problem number 3. Well, in the problem number 3, when you read the problem number 3, it says, well, coal is carried from a mine in West Virginia, etc., to a power plant in New York, etc. And then there's there's a mu, right? And there's a sigma. All right. So mu, you have your sigma. So you're gonna probably convert some variable to z. But here the question, it says, what's the probability that 40 cars chosen at random will have a mean load X bar, right? Here it says specifically it's X bar less than 74. So you want your X bar less than 74, not X, right? So here it says, so this is problem theme. So in this problem theme, it's probably that X bar, right? The last sentence in the question in the problem, it says X bar less than 74. So X bar less than 74. So the idea is the same. We need to convert this X bar to the Z, but the difference is we have like a different formula, slightly different. It's not, so your mu, again, mu is 75, your sigma is 5. So when you convert this X bar, so it will be 74 over, minus, of course, minus mu, sorry, 74 minus mu, which is 75, but then divide by sigma, but then you need to divide this sigma, this 5 by square root of n. N, that's the size of the sample. So here it says we have 40 cars, right? So we have a sample of, the size of our sample is 40. So we have to divide by the square root of 40. So this is the unique difference with the previous problem. So you need to divide this sigma by the square root of the size of the sample. Okay, so here we have size of the sample is 40. All right. Again, guys, if you read again problem number 2, in the problem number 2, there was no sample, right? We have mu, we have the sigma, and then, right, there was no X bar, there was no sample, right, in problem number 2. So problem number 3, we have this sample of 40 cars, right? And the question is, it's specifically about the X bar, right? So, yeah. And then of course, this is supposed to be Z, of course. When you convert, this is supposed to be Z, of course. So this is how you convert X bar to Z. And then again, use this table 3 and yeah. Is there any question about this problem number 3? Let's see the chat. All right. Okay, so now let's move to the problem number 4. So in problem number 4, well, again, there is this percentage, right? First sentence says recent study shows that 70% of college students hate mathematics, right? So it's 70%. So there is this percentage. So you see this percentage. So that percentage will be your probability of success. So you have a binomial distribution. There is this percentage. So that will be your binomial distribution. So the percentage will be your probability of success. So that's the 70%, right? And then you should expect, like in the next sentence, to have the number of trials or the size of the sample. So it says in a class of 50 students, right? So we have this sample of 50 students, right? So your N would be the number of trials, or size of the sample would be 50, right? Well, the problem here, this 50, this number N, which is 50, right? It's not in this table number 2. So there's no way we can use the table number 2 because this is more than 20, right? This is more than 20. So there is no way we cannot use, cannot use the table number 2. Okay. So the idea here is, well, to convert this, this probability of success, or this is the variable, the number of successes R to the variable Z, right? So, so for example, it says, so we have this number of trials, again, 50, and it says, what's the probability that 38 or more hate mathematics, right? 38 or more. So we're gonna find the probability that number of successes are 38 or more. So it's more or equal to 38. Right? More or equal to 38. Okay. Well, of course, if you had your table, well, then this would be, so more or equal to 38, that would be 38, 39, 40. So we have a group of 50, right? So the maximum number of students you can have is 50, right? So it's 38 plus 39 plus 40 plus 41, etc. to 50, right? But as I said, there's no way to use table here. So the idea is to convert. So we need to convert this R first to X, and then to a continuous variable, and then so this is R. So I'm going to convert to X first. And the way to convert to X, because it's more or equal to 38, okay? So this is 38. This is your distribution. So it's more or equal to 38. So that would be the right. That's the right to the right of 38. And the thing is, you want to include the 38. So we need to move your 38 a little bit to the left. So then you can include the 38 in your probability, right? So if you move 38 a little bit to the left, so we need to subtract 0.5. So that's 38 minus 0.5. So you want your X to be more or equal to the 38 minus 0.5, that's 37.5. All right, so I converted R to X. Now, next step is to convert X to Z. And the way we convert X to Z is using mu and sigma. But mu and sigma are not given here. There's no mu and there's no sigma. But the thing is, this is a binomial distribution, so we know how to compute the mu. The mu, it's n times p, and we know how to compute the sigma. So then I can convert my X to Z. So that's Z more than, so 37 minus, so like in this problem, n times p, 50 times p, 70%, that would be 35, I guess, over, so this is 35, right, over sigma, which is square root of n times p times q, which is, I think it's 3 point something. But anyway, so it's over sigma. And etc. Then this is more, so this is the area to the right. So the table 3 gives us the area to the left. So it's 1 minus, the area to the left. So this is the area to the right, of course, and etc. Like in the next question, it says 34 or less. Okay, so instead of R,
we had to do at the end, we had to do 1 minus the number we got,
yeah,
right?
Yeah, absolutely. So it's like 1 minus, 1 minus, wherever you get from the table. Yeah.
Okay.
Absolutely. So like the next question said 34 or less, hey, mathematics. So it's not, so here it's R. We would have like R less or equal to 34. So yeah, so again, the idea is the same. The only difference is that here, because R is less or equal, so when you convert to X, a continuous variable, X would be 34 plus 0.5. So this is, when you have less, this is less. So it's 34 plus 0.5. Okay, so that's the only difference with the previous. Well, of course, this is less. So you can actually, when you convert to Z, you can get the answer from the table, right? Etc. Let me just say, let me see the chat. If there's anything in the chat. No. Okay. Let me just say one word about the last question in this problem. It says 16 or more like mathematics, right? So that's different from the previous questions, because in the previous question, it was like, 34 or less or 38 or more hate, right? Mathematics. And the 70%, that's the percentage of students who hate mathematics, right? So in the number 3, question 3, it says, question 3. So it says 16 or more they like mathematics. So to answer this question, you have like two options. The first option is to switch the P and Q. So, in the previous questions, our P was 70%, right? And our Q, of course, that's 1 minus P. So what we can do here in this first option, so in the previous question, or two questions actually, the previous questions, so P was like 70% and Q was 1 minus 70%, that's 30%. So here we need to use, we can switch P and Q. So here we switch P and Q. All right, so then to answer this question, we need to use P equal to 30% and Q equal to 70%. Okay, so like so then you need to find probability that R is more or equal to 16, right? So you convert to X as usual. So X is more or equal to, so this is more. So you need to move your 16 a little bit to the left. So you subtract 0.5, minus 0.5. All right, so nothing, this is the same as the previous questions. So this is X more than 15.5. But then here, when you convert to Z, right? So this is Z more. So here you need to be careful. So 15.5 minus, so the mu is gonna be different than the mu we used in the previous question. So mu here would be like N times P. So your N is, again, we have 50 students, right? But P, it's not 17% anymore. So P here would be 30%. So 50 times 30%, or so 30%, that's 0.30. So times 0.30, that would be equal to 15, of course. So this is 15. Okay. So this is your new mu. Okay. So this is Z more equal to 15.5 minus 15, right? That's different from the mu we used before, right? The mu we used before is 35. So in this question, because because we switch P and Q, so we have a new mean mu. So now it's 15, but the sigma is going to be the same as the previous question. So this is sigma the same as the previous question, or previous two questions actually. It doesn't change because even when you switch P and Q, the sigma stays the same. So that's your first option. The second option is just to, take the opposite statement. So the second option, if you don't want to switch your P and Q, second option is just to, so if you know that 16 or more hate mathematics, so the opposite statement would be, well, so 16, you have a group of 50, so then you have 50 minus 16 left. So 50 or 50 minus 16 or so more, so the opposite would be less. Hate, the opposite would be like, it's 16 or more like mathematics, of course. Sorry, this is like, so 16 or more like mathematics. So the opposite to like, of course, would be hate mathematics. Okay, and then you can just use, the same mu, same Q as we had in the previous questions, right? So here, the mu would be 35 and sigma just the same. All right. Let's just check the chat. Last question. I think the last question, I think people got confused a little bit. So in the problem number 5, so this is about the confidence interval, right? So problem number 5. So it says, you have to find this confidence interval, right? 95% or 99% confidence interval, etc. So it's about confidence interval, right? Now, in the confidence interval, there are like 2 cases. Confidence interval. There is the first case when where sigma is given or known, right? It's given in the problem. And there is a second case when sigma is unknown, right? All right. So let's do the first question here. So it says Jordan is a manager of a used bookstore, etc. He wants to estimate the average amount a customer spends per visit. So we have random sample of 20 customers, etc. Have the mean of X bar equal to $6.90, right? So it says, so we have this X bar, right? Because in the confidence interval, the answer should be like confidence interval. The answer in both cases, it doesn't matter if sigma is known or unknown. It's always of the form like X bar, you have minus E, and X bar plus E. So X bar, it's of course given, right? It's in the problem here. It says X bar, it's $6.90, right? So this is X bar, it's $6.90. All right, that's given. Now the problem is to find this E, right? This is the error E. You need to compute this error E. So to compute this error E, there are 2 cases. So it depends on if sigma is known or unknown. So like in the first question, it says, suppose the sample standard deviation of the 20 receives was S equal to, so S, it's not sigma, right? There's a difference between S and sigma. S, that's the sample standard deviation. The sigma, that's the population standard deviation, right? So there is a huge difference between S and sigma. So it says, so in the first part of the question, it says, so it says, so this is question 1. So it says, S is equal to $2.10. And then you have to find this 95 confidence interval, right? So this is S, this is not sigma. This is not sigma. So sigma is unknown in this case. It's not given. Sigma is not given. It's unknown. That's S, that's not sigma. And when sigma is unknown, the formula for this error E, right? We need to find this error E, right? So the formula of this error E would be like this T, variable T subscript C times S, right? Over square root of N, where N is the size of the sample. Now, how do we find this, this variable T? Well, this is from table number 4. Okay. The S, it's given, right? So we have this T subscript C. S, as we said, is $2.10 over square root of N, and that's the size of the sample. We have a sample of 20 receipts, right? So 20, so that's square root of 20. Now, we need to find this T subscript C, right? And we said that's from table 4. And that's because sigma is unknown. So we have to find this T subscript C. So table 4, so we need the confidence level. It says 95. Confidence level C. Confidence level. It says it's 95%, right? Or in other words, that's 0.95. And you need the degree of freedom. So for this table number 4, you need this degree of freedom, which is just n minus 1. So it's n minus 1. Don't forget to subtract 1. So n is 20 because we have a sample of 20 receipts, right? So it's 20 minus 1. it's 19. So my degree of freedom is 19 and my confidence level, it's 0.95. So let's go to this table number 4. Table 4, it's right here. So the first column, you see the D point or D dot F dot, that's the degree of freedom. So it starts with 1, 2, 3, 4. You know, our degree of freedom is 19, so we need to go all the way down to 19. And then the C, confidence level, forget about the one tail area and the two tail area. That's not, it's not part of the table. Just forget about the one tail and two tail, right? So we can start with the third row. And the third row, it starts with 0.500, then 0.750, etc., right? Our confidence interval, it's 95. So that's 95%. So that's 0.950. So you need to go to 0.950. And then degree of freedom is 19. So the answer will be 2.093. So it's 2.093. So this is your T, this T subscript C is actually 2.093. So here, this would be 2.093. So just be careful. So sigma here, it's unknown, it's not given. So we need to use this table 4, right? This T subscript C. Now, the next question, right? Now next, it says like, suppose that instead of calculating the sample standard deviation, etc., Jordan knew from prior information that the population standard deviation is sigma. You see, sigma is $2.45. So sigma here is given. It's known, right? So when it's known, that would be, we're gonna have a different formula for this error E. So instead of this T subscript C, we use the Z subscript C. So in the question number 2, or the second question, oops, sorry. So the second question, you know, it says, so we need to read carefully the problem, guys. So it says the population standard deviation sigma is 2.45. So sigma is given. So sigma is known. So in this case, our error E would be, instead of T subscript C, that would be Z subscript C times sigma is 2.45 over square root of, square root of n. That's your square root of 20. And the way to find this Z subscript C, of course, is using the, this small table, in the bottom of the table V. So that's where you find where Z subscript C. All right. So this was, I think, this is the most common mistake in this test. So number 1, most of you actually, instead of using this T subscript C, because sigma is unknown, most of you actually use the table V instead of the table 4. But you see the difference, guys, between the first and the second question? You see the first question, there's no sigma at all, right? It's just S. So that's where we use the T subscript C. Any remark, any question, any comment about this problem number 5? And then, of course, once you compute your E, then the interval is just x bar minus E, x bar plus E.
Well, it's clear to me now. I was confused when I was taking the test. I ran out of time, so the only thing I was able to do was
I think kind of, yeah. That was, as I said, this is like the most common mistake. I think in both questions you use this Z. I think you use this Z subscript C. But yeah,
I did, right? Wow.
Yeah. Mm-hmm. All right, guys, we have like 45 minutes now to. So this was your test, right? Yeah, and I think in the final you're gonna probably have similar problems. Okay, this is because they are very important problems. So we're gonna probably have the same, not the same, of course, the different numbers, I guess, but it's just very similar problems in the final. Okay, so I mean, be prepared. I mean, All right, now what about the first chapters? All right, so let's now discuss the first chapters. All right, so we're gonna discuss now the review sheet for the final. This is
Professor, when we get the review sheet, I know the test wasn't like that, but will the final have, like, you know how you did our first test one when it was section and then the section? Is this one just gonna be like just all the questions and you have to know the section that's going in order?
Yep. Yeah. It's gonna follow. I mean, the final is gonna follow like the order of the sections order. Yeah.
Okay.
Yeah, like from the first. I mean, from the first section to the last one. Yeah. Okay. Yeah, they're gonna follow the same order. Yeah. All right. So this is a review sheet for the final. All right. So I guess because we discussed the problems in the second test, so we can now we can just skip the problems related to the chapters 6, 7, and 8, right? Because that was your second test. So let's discuss now. So there's the first section, which is actually section 2.1, where we discuss this frequency table, classes boundaries, etc. I mean, I won't really solve the problem here in your review sheet because I'm gonna just remind you, the main steps, right? So this is section 2.1. So section 2.1 was about this frequency table, right? So yeah. So the first and the most important. So when you make this frequency table, so you need to make a frequency table, etc. Just remind you the main formula, which is the width of each class, right? So this is a frequency table. So always the first step, whenever you want to make a frequency table, is to compute the width, right? So the width, just remind you the width of your classes or your intervals. You take the largest, the largest data value minus the smallest data value, right? And then you divide by the number of classes. Again, it's the number of classes. It's not the number of your data values. So like in the first problem in the review sheet, the largest value, I think it's 44, if I'm not mistaken. So the largest value, I think it's 44. Please correct me, guys, if I made a mistake or something. So the smallest value, I think it's 2, right?
So the largest is 51.
51? Did I miss the 51? Where is it? I don't see the 50.
No, 61.
Oh, 61.
Yeah.
Oh, that's the second number. Yeah, thank you. sorry. Thank you. I appreciate Yanni. Yeah, actually 61. I didn't see the 61. Thank you, Yanni. And divide by the number of classes, right? It says, in this problem, it says, we need to make this frequency table with 5 classes, right? So we need to divide by 5. So this is 59 divided by 5, which is, I guess, 11.8. So your width would be the next, don't forget to take the next whole number or next integer, okay? Next whole number. So the next whole number, of course, would be 12. Okay, so it's 12. Your width is 12. And then for the classes, guys, I won't solve the whole problem here. I'm just gonna remind you what we do, like the main steps. So like the classes, what does it say? You need to find, so make this frequency table with 5 classes showing classes boundaries. So first you need to find the classes limits, right? So with classes limits, guys, you start with the smallest data value, which is, we said it's 2, right? And then for the next class or next interval, you're gonna add the width. So this is plus 12. So it's 2 plus 12, which is 14, right? So plus 12 again, that will be 26, plus 12 again. 38, etc. Plus 12, plus 12 will be 50. 1, 2, 3, 4, 5. We have now the lower limits of our 5 classes. Now, first class is going to be from 12. So this is from 2 to so what we do is we take the lower limit of the second class and we subtract 1. We always subtract 1. So it's going to be first class is going to be from 2 to 13. So we subtract 1. So this is from 2 to 13. Okay, and then for the upper limit of the second class, we're going to add 12, plus 12, plus 12, etc. So that's how we get the classes limits. Classes boundaries, don't forget for classes boundaries, you need to subtract and add classes boundaries. Like for the first class, the lower boundary would be, so we need to subtract 0.5 from 2. So it's 2 minus 0.5, that will be 1.5. And for the upper boundary, you're gonna add 0.5. So that's 13.5, okay? So lower limit or lower boundary, you subtract 0.5. For upper boundary, you add 0.5, etc. Right? So we do the same thing for the 5 classes. Etc. So class midpoints, frequencies, etc. I think it will be a good idea actually to move to the next problems because so I think this is again you can compute the midpoints, frequencies. So I think this frequency table I don't think it's really hard. But anyway, guys, because we don't have really much time, so I need to move to the more important problems. But of course, if you have questions, you can email me, right? Etc. So, but I would say the most important thing here, just the width would be like that's the most important thing here. Once you get your width, you find your classes, and everything else is not. I don't think it's really hard. All right. Unless you have a question, guys, I'm gonna move to the next section because I think it's probably more important. All right, so let me move to the section 3.1. So this is where we discuss the mean, median, and the mode. So like here we have 5, 4, 7, 5, 2, 5, 8, and then 5. Right. So how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 data values. All right. So first, it says you need to find the mean. Right. So the mean, it's just take the sum of all the numbers. So 5 plus 4 plus 7 plus 5 plus 2 plus 5 plus 8 plus 5, right? And then you divide by the number of data values. We have 8 numbers, so we're gonna divide by 8, right? We divide by 8 because we have 8 data values. We have 8 numbers. We have 8 numbers. That's why we divide by 8. And that's how we compute the mean, right? And then you need to find the median. So the median, so this is the mean and then the median. So first step in the median, you need to order median. So step 1. So you need to order your data values from the smallest to the largest. From the smallest to the largest. Right? So like the smallest number is 2. We have only 1, 2, 3s. There are no 3s. 4. There is 1, 4. And then 5. We have like 1, 2, 3, 4, 5s. So 1, 2, 3, 4, 5s. Do we have 6? No 6. There is a 7. And then there is 8. All right. So you order from smallest to largest, and then you need to find. So step 2. The middle position of So we need to find the middle position, right? So here we said how many? 1, 2, 3, 4, 5, 6, 7, 8, right? So the middle, we have 8 numbers. We have 8 numbers. And that's, 8 numbers. So the middle, what we do is we need to add 1. You always add 1, right? So it's 8 plus 1, okay? Always plus 1. You have 8 numbers, it's 8 plus 1. You have 20 numbers, it's 20 plus 1, and then divide by 2. So then you can find the middle, okay? Always divide by 2 to find the middle. So it's 9 over 2, that's 4.5. So the middle position is 4.5. So that's not the answer, okay? That's not the median, right? This is, I think some of you got confused with this thing here. So this is not the median, okay? This is just the middle position. That's the middle position. So it says 4.5, which means that the middle is actually between the 4th number and the 5th number. So then the middle is between the 4th, because it's 4.5, so it's between 4 and 5. So it's between the 4th position and the 5th position. Right. So like this is my first position, 2nd, 3rd. So this 5 here, this is the 4th position, right? This is at the 4th position, and this 5, it's at the 5th position. So I have 2 numbers, right? One at the 4th position and another one at the 5th position. So then the answer, your median, would be the average of the 2 numbers. So the answer, this is a step 3. So then the median, you take the number at the 4th position. At the 4th position, we have 5, plus the number at the 5th position, which is also 5. It's just a coincidence that we have the same number at both positions, right? So in general, you're gonna have like different numbers. But in this example, it's in the 4th and the 5th positions, we have the same number. So it's 5 plus 5, and then you take the average. You always divide by 2. So here it's 10 over 2. So the median is 5. All right, guys? So again, the 4.5, that's not the answer. That's just the position of the middle position, right? Any question? Let me see that. Sorry. Chat. Right. So that's for the median. And then there's the mode, right? The mode is just the most frequent number, right? So here, as you can see, we have 4 5s. So the most frequent number, of course, is 5, right? So the mode, most frequent number. And so in this case, that would be 5. All right. Please let me know, guys, if you have any questions, right? So that's for the mean, median, and mode, which are, I think, are very important. Now, next question is, oh yeah, when you have this weighted average. So in B, that's next question. This is B. So it says, so in Math 21, weights are assigned to assignments as follows. You know, you have a research project worth 15%, exam 20%, exam 2, 20%, etc. So let me just write down here. So research project is worth 15%. There is exam 1 worth 20%, exam 2 worth 20%, exam there's this exam 3 worth 20%, and then there is a final, it's worth 25%. So the percentages here, guys, are the weights. So that's why I call the weights. So those are the weights, So like the weight of the research project is 15% because it's worth 15%, okay, etc. All right. Now it says, so there's Lewis. Lewis, he got like, now so Lewis's scores or Lewis's grades. So Lewis got 70% on the project, etc., right? So, and then the question is compute his weighted average in this class. In math should be math 21, not math 22. But anyway, so the weighted average. So the way we compute the weighted average. So what we do is the following. So we need to multiply each weight by the corresponding grade. For example, so Lewis, he got 70 points on the project, right? So his score or his grade on the project is 70 points, right? So we'll multiply the 70 by the weight of the research project. So it's 15%, right? So we multiply the 70 by the 15. So multiplied by the 15%. Instead of percent, I'm gonna use this decimal, all right? So like 15%, the percent means division by 100. So 15%, that's 0.15, right? So 70 multiplied by 0.15, right? Because his grade or his score on the project is 70. So 70 times 0.15, right? That's the weight.
So it's gonna be 0.70 because it was 70%?
Yeah, here it says 70 points. Yeah, just just 70. Yeah, whatever it says. If it says like Lewis earned 70%, then use 70%. Just here it says 70 points. So I'm gonna just use the 70 points. And then yeah, so plus. There's a plus. So you need to add for the next exam, exam 1, he got 80 points. So that's 80 points times. So how much is worth the first exam? It's 20%. So times 0.20, right? Plus, etc. Next exam, he got 90 points. So that's plus 90 times, and the second exam is worth 20%. So it's times 0.2 again. Third exam, it's 60 times, again, 0.2. And the final is worth 25%. He got and the final 82. So that's 82 times 0.25. 0.25. Okay. And so this whole thing divided by the sum of the weights. So the weight of the research project is 15%. So that's 0.15. The weight of the first exam is 20%. So plus 0.20, plus 0.20, plus 0.20. And plus 0.25. So in the denominator, we take the sum of the weights. Sum of the weights. Right? And don't forget, guys, in the top, in the numerator, you need to multiply first, right? Because PEMDAS rule, multiplication first. So first, you need to multiply the 70 by 0.015. The 80 by the 0.20, 90 by 0.20, etc. So multiplication first. Once you are done with the multiplication, then you can add, right? And then that will be your top. And then denominator actually is going to be equal to 1. But anyway, so don't forget, multiply first. You need to multiply first, and then you can add. All right. Any question? Let me see the chat. All right. So this is, yeah, the weighted average. All right, no questions. So then let's move to the, all right. Next question, so problem 3. That's a range, sample variance, sample standard deviation. Let me see. Okay, let's, all right, let me first discuss the most important problems. I think are very important. And then I'm not sure we're gonna have time, but let me discuss problem number 4, section 4.1. So this is problem 4, section 4.1. So in this section, we've discussed the scatter diagram, the sample correlation coefficient, etc. I think the computation for the sample correlation coefficient is very complicated. The R, it's very complicated. I think in the first test, most of you had the trouble to compute this R. So yeah, and it would take a lot of time actually. So I'm not saying it's gonna, well, I don't think the R is gonna be in the final because it takes a lot of time to compute the R. But what you need to know about this section 4.1 is how to plot the scatter diagram. So let me see. So here you have your X. There's this X. There's this Y. So your X is, so first X is 20, then 26, then it's 35, and then it's 29, and then it's 39. Corresponding Y, this is 23.4, this is 22.0, this is 16.1, 18.8, 15.7. So it says plot the scatter diagram of the data. So scatter diagram, just to remind you. So what we do is the following. Say again?
I said, I know you're not doing R, but can R be a negative?
Oh yeah, of course. R can be negative. R can be any number between -1 and +1. Yes, R can be any number. Yeah. All right. So yeah. So first, to plot the scatter diagram, you need to you're gonna need 2 axes. There is this horizontal axis, which is the x-axis, and there is a vertical axis, and that will be your y-axis, right? And so you plot the values of x on the x-axis, like here, x, the smallest x is 20. So let's say this is 20. Next value of x is probably 26. There's 29, and then there's 35, and then there's this 39, right? And then for the y, the smallest y is, I think it's what is it? 15.7. That's the smallest value of y. And then next value is 16.1. Next, it's 18.8. Then we have 22. And then we have 23.4, right? So how do we plot the scatter diagram? Well, you just take the first value of x, which is 20, and the corresponding y is 23.4. So this is your 20, x is 20. So we need to go up to 23.4. So that will be your first point. Okay, etc. So next x is 26, and your corresponding y is 22. So this is 26. Go up to 22, and that's your second point. 35, x is 35 is 16.1. This is 35, 16.1. So it will be this point. 29, it's right here. Corresponding y is 18.8. So we get this point. And then last point, 39, corresponding x is 15.7. So it's probably right here, somewhere right here, right? So we got this 5 points, right? Now, it says, where is it? Yeah, so it says, using only the scatter diagram, would you estimate the correlation coefficient to be positive, close to 0, or negative, right? So, so we need to draw like a line which passes through the points, right? So the closest line to these points would be probably this line right here. Let's say this line, okay? So that would be probably the closest closest line to these points. And it's, as you can see, it's a line which is going down, right? It's decreasing. So the line here, so the line is going down, or is going down, right? So when the line is going down, then would you estimate the correlation coefficient to be positive, close to 0 is negative. So when it's going down, then your R is, well, it's gonna be negative, right? Okay. So if you get a line which goes up, then your R would be positive, right? Etc. Yeah, so what else? Explain your answer. Yeah, so because, yeah, the explanation is just to say, well, your line is decreasing or going down, so then your R is negative, okay? Any question, guys? So I think this is the most important thing you need to know about this section: how to plot the scatter diagram and how to, how to estimate the correlation coefficient given given the scatter diagram you have. All right, let me move to the next. So let me move to the next section. Yeah, so let's do the problem, the third problem in the next section. I think this is a very important problem. So next section, section 5.2. This is about the probability rules. So we have this table, with freshman, sophomore, junior, and then senior, right? And then we have not satisfied, right? There's then neutral, and then satisfied, and then etc. We have the total, right? All right, so you're gonna find the probability that a student selected at random is satisfied, right? So probability that the student is satisfied. So what we do is we count, of course, how many satisfied students. So in total, for example, here we have 100 satisfied students, right? So in the top, we have the number of satisfied students, right? Because you want to find the probability that this student selected at random is satisfied. So the top, that's the number of satisfied students, and the denominator is supposed to be the sample, the size of the sample. Size of the sample. So we have, in total, we have 200 students. So the number of satisfied students is 100, and the total number of students is 200. So that's 100 over 200. So the answer is a half, or in a percentage, that will be 50%. So this is 1 over 2. Okay, so next it says, okay, this is important. It says probability that student selected at random is satisfied given that the student is a senior. So the student, given the student is senior. All right, so just be careful here, guys. I know this is a very common mistake. So when we have this word given, right, you need to be careful. So first, in the denominator, that will be the number, the total number of, because the given here, it says given the student is a senior, right? So you need to count how many seniors. So the denominator, that will be the number of seniors. Okay, because you know that the student is a senior. So your sample, it's not given by all the students. The sample is given only by senior students. So in the denominator, that's the total number of seniors. So the total number of seniors here, it's 100. So we need to divide by 100, right? Now, satisfied, given that the student is senior. So we need to go to the column where you have the senior students. So here, this is senior, right? So the question is, how many senior students satisfied, right? There's, you know, there's, here you have 60, here we have neutral is 10, and satisfied seniors, we have 30, right? So it's like, because it's given that the student is a senior, right? We know that the student is a senior, so we're gonna focus only on senior students, right? So how many are satisfied among the senior? Well, it's 30. So it's 30. So in the top, that will be 30. Okay. Satisfied, yeah, satisfied. It's 30. So 30. Right. So this is the number of satisfied, not just satisfied, but satisfied seniors. Okay. So given the student is senior, the denominator, the bottom, is given by the number of seniors. For example, if we try to do the E, in the E it says probability that the student selected at random is neutral, given that the student is a freshman. The student is freshman. Right? So here in the denominator, it's not the total number of students. So in the denominator, because the student is freshman, we know that the student is a freshman. So in the denominator, it's going to be the number of freshmen. Okay, this is the number of freshmen. Right? Because we know that the student is a freshman. So the sample is given by freshman students. So freshmen, we have, in total, we have 100 again. This is 100. The total number of freshmen is 100. Now, the top would be the number of neutral freshmen. The top, that's the neutral and freshmen. So neutral freshmen. So how many neutral freshmen? Well, neutral freshmen, we have 50, 50. All right, so this is for when it's a given. Now, or, let's do or. So it says, for example, in the C, it says probably that the student is junior or not satisfied. So, or, this is kind of so we need to remind you here the formula for or. So probability that A or B, this is probability of A plus probability of B minus probability of A and B. Okay. So the formula for or is, I would say it's the most complicated formula, because so this A or B, you have probability of A plus probability of B plus probability of A and B. So like in our problem, so this is junior or, right? It says or, not satisfied. So first we start with the first event, which is junior. So first we need probability that the student is a junior plus the probability that the student is not satisfied minus probability that the student is junior and not satisfied. All right, probability that the student is junior. Let's take the total number of junior students. Junior students, we have 100 over the total number of students is 200. So that's the probability that the student is junior. Not satisfied. So how many not satisfied in total? We have 200. Sorry, total number of students. It's a survey of, it should be 400, right? The total number of students is 400. That's a, I guess that's a mistake in the, it's a typo in the, right? The total number of students is actually 400. It's not 200. Sorry about that. So this should be, it's 400.
No, on this paper says 400. All the students together.
Oh yeah, no, but the first sentence, you see it said Committee on Student Life did a survey of 200 students, right?
Oh, okay.
Like yeah. That's should be 400, not 200, sorry. It should be 400 there. So yeah, like, so then, yeah, so this probability here, probability that the student is satisfied is 100 over 400. Should be 400 here. Total number of students, it's 400. It's not 200, sorry. So 1 over 4. So yeah, for junior, it's 100. We have 100 juniors over 400 students. And then not satisfied, we have 200 not satisfied students. So it's 200 in the top. That's the number of not satisfied over, again, we have a sample of 400. Minus junior and not satisfied. So junior and not satisfied. So you go to the table, junior and not satisfied, that would be this number right here, right? This is where it's junior and not satisfied, right? Not satisfied, right? Junior and not satisfied, that's 75, right? It's 75 here. So junior and not satisfied, that's 75. So minus 75 over 400. So, so that's 100 plus 200 minus 75 divided by the same common denominator, which is 400. So that's the 300 minus 75. That's 225 over 400. Or of course you can just, you know, if you don't want to add the fractions, you can do first, you know, you can just do 100 over 400. That'll be 1 over 4, which is 0. No, this would be like 0.25 plus, you know, 200 over 400. That's a half, 0.5 minus 75 over 400, which is, let's see, 12, what is it? Yeah, it's probably, let's see. Yeah, it's, you see, 75 over 400. So yeah, so it's actually equal to 0.18, 75. Okay. Anyway, you're gonna get the same answer either way, right? So this is for or. Now, when you have and, like D, it says neutral and freshman. So probably that the student is neutral and freshman. So when you have and, so it's the same time, neutral and freshman. So you need to go to the table where it says neutral and freshman. So neutral, where is neutral? So neutral is right here and freshman is not right here. So neutral and freshman would be this number, which is neutral and freshman, that's 50. So neutral and freshman at the same time, we have 50 students, neutral and freshman. So that's 50 over, you know, the total number of students, which is 400. So that's 1 over, I guess that's 1 over 8, which is, you know, 0. I think 12, 5. But anyway, so just when you have given, guys, just be careful when you have this word given, then you need to be careful with the denominator, okay? So the denominator, when you have this word given, the denominator is gonna be the total number of, you know, the given students. So for example, here it says given the student is senior, so denominator would be the total number of seniors, right? Here, given the student is freshman, so the denominator would be the total number of freshmen. Now, in the other cases, you know, when you have or and or wherever, the denominator, it's always, you know, the size of your sample, the total size of your sample. Okay. All right. Let's see. Yeah. So, any question, guys? Well, I guess, yeah, time is over anyway. So, but I mean, next section is this, section 6.1, which is chapter 6. I mean, we discussed this chapter 6 in the test number 2. Yeah, I think you probably have everything you need, you know, for the final. Yeah, as I said, you're gonna have, I think, 9 problems, 9 problems. Yeah, in the final. The final is longer than the second test. Yeah. Anyway, so if you have any question, guys, about this review sheet, please email me anytime. All right. Thank you, everyone. Thank you for listening. I will, of course, I will upload the recording on YouTube as usual, and I will send you the link later. All right, guys. Yeah.
All right.
Thank you.
Thank you.
Professor, change my time.
Say again. Sorry.
Are you able to change my time?
Yeah. So yeah. Okay.
That's okay.
Didn't we say we were gonna get like a boost if we came to all the classes at the end of the class for our grade? Professor?
Do y'all know if he's giving more time for the final or it's 2 hours as well?
I don't even know.
Sorry, guys. Sorry, I lost you. Sorry. I'm here again.
Hey, Professor.
I'm gonna just stop recording because